Hello everyone and welcome to the week 4 for our core systems integration and architecture. In today's lesson, we will be talking about systems integration technologies. By the time that you're watching this video, I hope that you are all safe and healthy. So let's start with our discussion. In integrating systems within an organization or an enterprise, it is important that we have an essential set of tools that we can use or implement, and middleware is one of those. Middleware bridges the gap between applications, tools, and databases to provide a unified service and optimize solutions to every user. It highlights here that middleware bridges the gap, meaning this serves as a tool that we need to utilize in order to efficiently connect every components of the systems or everything that we need to integrate within an organization. When we have middleware, the flow of data, the conduct of operation, and the performance within an organization will become better, will have a convergence, and will become more unified. For this lesson, here are our objectives. First, we need to identify what is a middleware, its models, and compare and contrast the different types of middleware for system integration. So what is a middleware? Middleware is any form of software that allows communication between two or more software systems. Middleware is an essential tool for systems, for tools, for the components to be able to communicate with one another. Look at the image there. It's the middleware that bridges everything from the application servers to the database to different transaction systems, even messaging systems. That is the relevance of having a middleware used in system integration. It might be as basic as an application to application communication link. That is the basic definition of what middleware will be all about. Or as complex as information exchange and logic execution method. So we can look at middleware in two perspectives. One is that it can be an application to application communication link or information exchange and logic execution methods. So why care about middleware? So here are some of the reasons that you need to consider when employing middleware in systems integration. So flash on your screen, on the left part of the slide, you see there an enterprise, a representation of an enterprise without middleware. So from point A to destination 1, 2, 3, 4, and 5, there are direct connections as well as from point B, point C, point D, and point E. So in short, without middleware, connections may be too complex and flow of data may have some sort of difficulty because of the communication between the applications involved. While in the other side of the screen, you see there with middleware. So the establishment of connections from point A to point 1, 2, 3, 4, and 5 becomes more simple, becomes more efficient, or optimized. So there is a convergence of the processes being performed from the source to the destination or from the target to the destination. So basically on the slide, you see the basic definition of why do we care about middleware. As simple as representing both picture, we have an initial idea of the relevance of having middleware in an enterprise or an organization as long as part of system integration or as far as integration is concerned rather. So there are two types of middleware models. The first part, we have the logical middleware model. So the logical middleware model conceptualizes how information travels within an organization. It's more on the logical part, because in this kind of model, we think of how are we going to allow data or information flows in an organization as far as we integrate the systems that we use in there. So the image that you are seeing right now is an example of how we logically design or conceptualize how information might flow or might travel in the organization. So that is the first type of a middleware model. So the other model that we have here is the physical middleware model. In the physical middleware model, both the actual mechanism of information flow and the technology used are depicted in the physical middleware model. So basically, in this kind of model, we present or we show the actual mechanism, how the information flows, and what kind of technology are we using in the organization. So we are not only focusing here on how information travels, that is the responsibility of the logical model. In here, we focuses more on the actual process. What are the technology used for conducting the flow of services or for implementing services within an organization. So here we have different concepts of how are we going to communicate or to connect. So one is point-to-point middleware. So in point-to-point middleware, to connect one program to another, point-to-point middleware employs a simple pipe. So the simple pipe establishes a direct link. Look at the word direct link between a source and a target application. As shown in the picture, we have there direct link from System E and System D, that is number 1. We also have direct link labeled as number 2 between System D and System A. Also, System C and System B with labels number 7, and System C and System E with label number 5. So you just have to remember that when we speak of point-to-point middleware, we establishes a direct link between the source and the target. Further, the inability to link more than two applications, the lack of capacity to house application logic, and the inability to modify messages as they travel through the pipe are all drawbacks of point-to-point middleware. Remember in the previous lesson when we talked about information oriented, there was a tendency that when the data flows from one application to another, some sort of changes might happen as it goes along with the integration server. But in here, in the point-to-point middleware, modification of messages as they travel through the pipe or through the direct link may be one of the problems or challenges that we may face when we use point-to-point middleware. On the other hand, when we talked about many-to-many middleware, it connects a large number of applications. So this kind of middleware connects not only one or two, but rather more systems or more applications within an enterprise. It can handle many sources and many target applications. As a result of these capabilities of this kind of middleware, it is the very ideal choice for application integration. You see the difference there between the point-to-point middleware and the many-to-many middleware. In here, this is an ideal choice for application integration, for it has the capability to connect 2, 3, 4 or more than a number of applications within an enterprise or an organization. It has a wide range of applicability and flexibility in the application integration sector. In here, we can apply the concepts that we learned from the previous lessons. Either we perform coupling or cohesion. So, another is synchronous and synchronous middleware. In an asynchronous mode, middleware transfers data between one or more applications. So the middleware software is therefore separated from the source and the destination application. Remember that the middleware software can be separated from the source and the destination application. Applications in the asynchronous middleware are actually not reliant on the processing of the other link application. But regardless of the condition of other applications, the application can always continue processing. Because you see there, one application is not so dependent or reliant on what is happening on the link system or link application. So it can still continue, it can still conduct its process, for it is in the asynchronous mode. We are more familiar now with the term asynchronous. Applications and synchronous middleware, on the other hand, are inextricably linked. So applications rely on synchronous middleware to handle one or more application or function calls rather at a distant application. They rely on the connection. To wait for the remote application to reply, the calling application must pause processing. So in the asynchronous, it can still continue its process. Like point A, when point A sends a request or a process to be performed, the other application, regardless of the condition of the other application who sent the messages, that sent the message, can always continue its process. But in the synchronous, it has to pause, it has to wait for it be able to continue or to conduct the process. So that is the difference between the asynchronous and the synchronous middleware. In the connection-oriented and connectionless, you see in the picture, we have their connection-oriented service and the connectionless service. Two parties connect, exchange messages, and ultimately disengage in connection-oriented communication. This is usually on a synchronous procedure, although it can be asynchronous as well. On the other hand, the caller application does not establish a connection with the destination process in the connectionless communication. The receiving application merely processes the request, and if necessary, it may respond. Look at the difference between the two. The other one requires connection so that the exchange of information can be done properly. But on the other hand, in the connectionless communication, regardless of the fact that one application may send request or not, and the response can be given or not, it doesn't necessarily require much. So that is the difference between connection-oriented and connectionless. In direct communication, we have here concept that we call direct communication. The middleware layer takes the message from the caller application and sends it straight to the remote application in direct communication. You have to remember this is way different from the point-to-point connection, okay? But in here, the caller gets the message and then the message directly sent to the receiver. With synchronous processing, either direct or deferred communication is employed. Direct is actually considered always as synchronous, whereas queued is typically asynchronous. Later, we will be talking about more on the queued type of communication or sending messages. The direct communication paradigm is used by the majority of the RPC-enabled middleware. RPC is one of the types of middleware that we will be talking about in the coming slides. This is the queued communication. In the previous slide, we talked about direct communication. In here, we will be talking about the queued communication. In most cases, queuing communication necessitates the use of a queue manager. So we have here the queue manager to place the message in a queue. It's like falling in line. First in, first out basis. When the messages comes, it caters first which comes first and which comes last would be in a less priority. The message is then retrieved by the remote application either immediately after it has been sent or any point in the future. So it is more on the asynchronous process. The information travels back through the queuing mechanism if the caller application demands a response, such as verification message or data. Queued communication is often used by the majority of message-oriented middleware. In the previous slide, we saw there RPC-oriented, and here we see message-oriented middleware. This is another type of middleware. In queued communication further, the benefit of queuing communication over direct communication is that the distant program does not need to be running in order for the calling program to send it a message. So it doesn't require that the receiving or the target program is running so that it can receive the message because we have the queue manager. Further, queuing communication middleware generally does not prevent the calling or remote application from completing their task. It doesn't require to immediately perform or conduct the operation. So that is the essence of having a queue manager. It has to wait in order for the request to be performed. This is more on in asynchronous operation or concept. The publish and subscribe, on the other hand, removes the requirement for an application to know anything about the destination application. All it needs to do is transmit the data it wants to share to a destination within the publish subscribe engine. So it is sometimes known as the broker. The information is subsequently redistributed by the broker to any apps that are interested. So it doesn't necessarily require to know what are the information of the publisher, what are the things that the publisher needs to know for the subscriber. It doesn't goes that way. All it needs to do is to transmit the data, and then the receiver gets it if it requires the data, and leave it if it doesn't need the data. The request response type is not exactly what it says on the tin. Request response middleware is used to send a request to an application and application response. Just simple as that. The target receives the request from the source and vice versa. Any middleware that may support a response from a request between applications such as integration server or application servers are examples of request and response. Lastly, we have here the fire and the forget. So what do we mean by the fire and forget approach? The fire and forget approach enables a middleware user to fire off a message and then forget about it. Once the message is transmitted, it forgets about it, without having to worry about who gets it or even if it is ever received rather. All it needs to do is to fire off, to send the message, and it doesn't think about if the receiver have received the message or if somebody receives the message. Another instance of an asynchronous method is this approach, the fire and forget approach. The goal of fire and forget approach is to let a source or destination application sends out a particular sort of message to a large number of people while avoiding auditing and response features. So the goal there, the ultimate goal is to send it in a large number of recipients. It also enables central servers to send messages out. So regardless if it received, if the target received or not, it doesn't concern the approach. The concern of the approach is all about sending a message to a large number of recipients only. Here we have different types of middleware. In the previous slides, we talked about the different approaches of middleware that it performs. Now, let's talk about the different types of middleware. First, we have the RPC. Next, we have the message-oriented middleware. Third, we have the distributed objects. We have the database-oriented middleware, transactional middleware, and the integration servers. For the RPC or the remote produce calls, this is the oldest kind of middleware. It allows the user to execute a function from one application and have it run in another application on a distant system. It's like, as you see in the slide or the figure, from the source destination, it says there feed the cat. And using the middleware RPC or the remote produce calls, it is being run or performed in another target or on the destination, where we have here the example open can, pour into bowl, and call cat. So you see there, the RPC has this function. It executes the application from one source and have it run in another source, or another target rather. So RPC's operation is synchronous. They also need more bandwidth than other middleware kinds. So the advantage of RPC is its ease of use in terms of mechanism and programming. Its disadvantage, on the other hand, are the enormous performance costs and its difficulty to scale. Another is the message-oriented middleware, or the MOM. In MOM, it is kind of queuing software that uses messages to transport data from one location to another. MOM communicates amongst apps via the concept of messages. So messages is the means of communicating from one app to another. It is not necessary to have a direct connection between the middleware mechanism and the application. Remember that. It is not necessary to have connection between the source and the target. The asynchronous paradigm is used by MOM. If RPC requires synchronous, MOM, on the other hand, requires asynchronous. This enables the program to run on its own. Messages are dispatched to a queue message in MOM, or a queue manager, which ensures that they are delivered to their intended recipients. In MOM, messages are actually returned to the caller application as soon as the calling determines the time. Now, another information that you need to know about MOM is that it makes it simple to maintain, since it has a structure, or like a schema, and content, which is data. And in this case, we have a message as one of the essential elements of MOM. MOM may be viewed as a single record database that is shared among apps. Look at that statement. MOM is viewed as a single record database that is shared among apps. Message passing methods are used to send and receive information, and point-to-point and message queuing are the two communication models supported by MOM. So we see there in the previous slides the different approaches. One is point-to-point and other is the message queuing, wherein we have a queue manager. Distributed objects, on the other hand, says here, small application programs that interact with one another using common interfaces and protocols. It provides methods for application development, as well as enterprise-wide method sharing and supporting technologies. So from the word itself, distributed objects. In today's market, there are two sorts of dispersed items. First one is the COBRA, or the Common Object Request Broker Architecture, and the COM, the Component Object Model. You might be seeing already this COM in your devices, in your communication devices, like your laptops. You have there the COM, and some have already been introduced to COBRA. Database-oriented middleware, on the other hand, makes it easier for an application or two databases to communicate with each other. It may be used as a technique to extract data from both local and distant database. So we have this kind also of middleware that focuses more on database, or this is called the database-oriented middleware. Call level interfaces, or CLI, and native database middleware are the two types of databases with which it interacts. CLIs are standard APIs, or application programming interfaces, that cover a wide range of database formats, allowing users to access several databases through a single well-defined interface like open database, connectivity, or an ODBC. So ODBC is an example of this one, which you can see when you connect your IDE going to your databases like SQL, database IDEs like SQL, YOG, or Access, Microsoft Access. Transaction-oriented middleware, or TOM, provides a framework for coordinating information flow and sharing methods across many resources. It enables integration that is strongly linked. So it necessitates, or it's very important that modifications to the source and target apps will be performed. Transaction-oriented middleware is built on the notion of transaction. It's like a day-to-day operation in which a discrete unit of work with a start and end date. So every transaction has a beginning and an end. A transaction is a container for application logic. And the transaction either completes or is entirely turned back. TP monitors and application servers are two forms of transaction-oriented middleware. Integration servers, on the other hand, allows data to flow between two or more resources while accounting for variations in application semantics and platforms without requiring any application to comprehend the other application with which it shares data. That is the integration server. And I think that is the final type of middleware that we have in this session. Okay? So for the summary of our discussion, we talked about the definition of middleware, which is a form of software that allows communications between two or more software. We also talked about different approaches that the middleware performs in order to send messages. We talked about middleware models like logical and physical. Here are the different approaches or categories like point-to-point, many-to-many, synchronous and asynchronous, direct communication, queued communication. We also have fire and forget and the like. And we were introduced to different types of middleware like the RPC, the MOM, the distributed objects, the database-oriented middleware, the transactional middleware, and integration servers. So I hope that you learned something from this discussion on the different types of middleware, different models, and the different approaches in which middleware performs to send different like messages from target to destination. Now that ends our discussion for this lesson. Thank you so much for taking time to listen and watch this video, and I hope that you keep yourself safe and healthy all the time. Thank you.